Greece's famous tourist destination Santorini is emptying out. More than 11,000 people, locals and tourists, have fled in just days.
In the last 2 days, at least 200 minor earthquakes were recorded in the archipelago, with the strongest being of magnitude 4.6 on the Richter scale.
A new geological update has revealed significant activity beneath Santorini. Recent seismic data confirm a magma intrusion, with land deformation, inflation, and deflation patterns signaling changes in the underground reservoir. An official report, update note on ground deformation at Santorini, estimates the magma volume involved in this ongoing crisis. Leading institutions, including CNRS, the National Observatory of Athens, and Greek universities, conducted the research, shedding light on the region's seismic shifts. Discover the secrets of MuskMind. Hit like and subscribe now. Rising concerns over Columbo underwater volcano. Just 7 kilometers 4 miles from Santorini, the Columbo submarine volcano is showing worrying signs. In December, researchers detected a rapidly filling shallow magma chamber, reaching pre-eruption levels. Columbo's history of explosive eruptions, combined with increased seismic activity near its main crater, has raised concerns. Additional monitoring stations were installed last year, with 4 more added recently. However, fragmented data ownership and poor institutional coordination limit access to crucial information. Currently, only 3 GNSS stations are operational, down from 10 during the 2011 to 2012 unrest, creating gaps in analysis. Ground deformation and magma movement. Recent data show land deformation accelerating since mid-2024, especially near the SN station. Elevation shifts jumped from 60 millimeters to over 100 millimeters, indicating a rising magma chamber. Other stations, HUS and Uranus, confirm movement trends, though at a lesser magnitude due to distance. Updated readings from February 11th reveal 3 key movements: uplift, northward drift, and a northeastward shift, mirroring the trajectory of recent seismic swarms. Notably, a deflation trend began on January 20th, followed by rapid acceleration toward the north-northeast on January 29th. Unexplained magma disappearance. Scientists note similarities to Iceland's Svartsengi region, where magma reservoirs inflated and emptied without eruptions. This phenomenon, known as magma intrusion, occurs when underground magma shifts without breaching the surface, akin to a stretched rubber band reaching its limit before redistributing pressure. The increasing deformation speed suggests intensifying underground forces, yet the simultaneous deflation raises critical questions. If magma isn't reaching the surface, where is it going? Santorini's seismic evolution remains a mystery, but with Columbo's explosive potential, ongoing monitoring is essential. Magma moves along the path of least resistance, infiltrating weaker zones like brittle rock formations. This movement deforms the surface, causing land uplift when a magma chamber expands, similar to inflating a balloon underground. When magma exits, the land subsides, creating a deflationary signal. Notably, deflation coincided with the second earthquake swarm, hinting at a possible connection, though exact timing remains uncertain. Seismic activity is a key indicator of magma migration. As magma forces through rock, it generates tremors similar to tunnel excavation. A dramatic example occurred in Iceland on November 10, 2023, when a massive intrusion formed a 15 km long dike extending toward GR and into the sea, triggering intense seismic activity. The ongoing seismic turbulence at Santorini raises a crucial question. Is this a prolonged magma intrusion? Persistent shaking suggests so, but fault lines could also be amplifying activity. If magma interacts with a fault, it may open new pathways, fueling further movement and setting off secondary ruptures, creating a chain reaction of seismic and volcanic activity. This evolving situation demands close monitoring. Recent data from 2025 highlights significant movement around the SN station, with deflation and shifting toward the north and east, aligning with observed ground deformation. Reports indicate rising land beneath Santorini's central island, raising concerns about magma accumulation. Satellite imagery and GNSS data confirm localized uplift, reinforcing suspicions of subsurface activity. A time series graph from January 2025 shows initial inflation, then deflation around January 29th, coinciding with the earthquake swarm. A brief stabilization was followed by another drop, mirroring periods of intense seismic activity, including a magnitude 5.3 quake. Did magma escape the chamber? A later rise in elevation suggests deeper sources may be replenishing the reservoir, triggering cycles of inflation and deflation, a pattern well documented in Iceland. There, eruptions are often followed by land subsidence, only for uplift to resume as fresh magma refills the chamber. Data from the Hias station shows stability through mid-2024, followed by a gradual 20 millimeters elevation increase. By January 2025, northward and eastward shifts accelerated, particularly around January 29th. Fluctuations in vertical displacement indicate ongoing subsurface pressure changes. Stations farther south still show deflation, though northward and eastward motion continues. The key question, is this purely tectonic, or does magma play a dominant role? While plate movement contributes to deformation, the evidence strongly suggests magmatic activity, particularly given the rising land beneath Santorini. If a magma dike or intrusion is forming, it can create depressions on either side, leading to localized subsidence as magma forces its way through the crust. This has been observed in Iceland, where magma-driven deformation forms valleys parallel to intrusions. However, data from Santorini remains limited, leaving uncertainty about the full scope of these movements. A purely tectonic explanation seems less likely. If this is indeed a magma intrusion, the best-case scenario is that enough magma has been displaced, reducing immediate pressure buildup. In this case, deformation could slow unless new fault lines activate or fresh magma pathways develop. Another possibility is a balanced flow scenario, where magma continuously rises while an ongoing eruption releases pressure. If this is happening, deformation and seismic activity could persist longer. Deep underground, magma moves through chambers, creating pathways for molten rock to reach the surface. As conduits form, seismic activity usually declines, similar to how an excavated tunnel stops, causing tremors. Before eruptions or intrusions, earthquake swarms occur, followed by a sudden eruption and then a drop in seismic activity. However, in this case, continued seismic unrest remains an anomaly, raising questions about the underlying processes. New geodetic data sheds light on ground deformation, tracking displacement rates before and during recent volcanic activity. From August 1st, 2024, to February 24th, 2025, land inflation persisted for 170 days, signaling ongoing magmatic activity. Similar swarms in 2011 to 2012 were confirmed as magmatic, drawing comparisons to the current situation. While minor measurement errors happen, consistent deformation patterns across monitoring stations indicate sustained unrest. Scientists analyzing Azov deformation, which tracks land movement direction, have pinpointed the likely source. The deformation field has shifted compared to 2011 to 2012, suggesting a new magma accumulation site. Estimates place the magma reservoir at a shallow depth of around 4.3 kilometers, similar to unrest seen beneath Iceland and Italy's Campi Flegrei. Even with alternative data points, the depth remains close to 4.8 kilometers, confirming that magma is near the surface. Based on deformation trends, approximately 6.5 million cubic meters of magma have accumulated at this depth. While not massive compared to Icelandic eruptions, Santorini's magma composition makes even moderate intrusions concerning due to its explosive potential. This volume corresponds to a maximum vertical uplift of 9 centimeters at the center of deformation. Assuming a steady inflation rate, this suggests a daily uplift of 1.1 millimeters, or about 33 millimeters per month. The most revealing changes occurred between early January and mid-February 2025. If the magma chamber's volume shifted significantly during this time, it could indicate whether magma is actively intruding, exiting, or redistributing. Current measurements at the SN station show deflation reaching nearly half of the previous inflation, suggesting complex dynamics. Some magma may have drained elsewhere or is adjusting pressure within the chamber. Unlike typical patterns, where seismic activity drops post-deformation, continued unrest raises uncertainty. Whether this signals an imminent eruption or prolonged instability remains unclear. Ongoing monitoring is crucial. Recent observations indicate about 3 million cubic meters of magma have left the chamber, reinforcing the idea of an active intrusion. The key question is whether the chamber undergoes cycles of refilling and depletion, a pattern seen in many volcanoes. If magma moved into a lateral dike, as often happens, it would now be lodged within the upper crust, seeking the easiest escape. A typical dike of 1 kilometer width and 30 kilometers length should be much thicker, yet current data suggests a mere 10 centimeters thickness, an unusually small but plausible measurement. Seismic activity clustering around this dike supports ongoing magma movement, increasing the likelihood that magma is driving the unrest. A puzzling aspect is rapid ground displacement to the north, with no clear explanation. To gain further insight, a GNSS receiver was installed on a small island east of Santorini on February 12th. Early readings have provided preliminary data, but with only hours of measurements, the significance remains uncertain. More data in the coming days may reveal clearer regional dynamics. A major gap remains in available data. Columbo underwater volcano, near the earthquake swarm's epicenter, is a key area of concern. Yet, real-time updates from its monitoring stations are scarce. Given its proximity and tectonic role, signs of increased unrest there could be crucial. The lack of data leaves a blind spot in fully assessing Santorini's seismic and magmatic activity. While predicting the next phase is challenging, these findings offer deeper insight into the processes at work. Make sure to subscribe to MuskMind for more intriguing and informative content. Thanks for tuning in.